Hey there and welcome back. So last time we looked at a lot of fixes for our game and we improved a couple of problems that we had. So this time we're going to look at custom tiles. Now I'm going to assume that you know what tiles are in NESmaker. And just to be sure, you know that we have these collisions over here. And these are tile types. So we have our null tile, solid tile, hurt tile, warp tile, and so on. So in this video, we're going to look at how we can make custom tile types. Now, if you remember when we set up our Jack the Chick game, we imported a lot of stuff. And one of those things was let's go to our Jack the Chick folder, game engine data, routines, base 4.5, game, and mod Metroidvania. So we copied a folder called tiles in here. Now this was not here by default. So I made this tiles folder and I included these 4 files in there. So these are the custom tiles in Jack the Chick. Now, you probably, if you have worked a little with this before, you probably recognize these two. The checkpoint tile and the trampoline tile. Those are the default scripts. However, I have modified them slightly. Well, the checkpoint one I have modified slightly. The trampoline one I have modified a little bit more. But anyway, these are the 4 custom scripts, tile scripts in Jack the Chick. So before we get started, let's just take a look at where we can add or modify tile scripts. Now once again, we have to go to our project settings up here. And we need to go to script settings and we need to go down to where it says there we go, tile types. So sort of like in the middle here. So under tile types you can see that we have 16 different tile types. Now the first one says blank tile. That's obviously the null tile. And then we have the solid tile, hurt tile, and so on. So these correspond with the tiles, the collision type that we choose from the list when we design our screens. So for example, tile 1, as I'm sure you know, tile 1 is a solid tile. And as you can see here, it has the solid tile code attached to it. So we can actually make our own tile script and attach it to a certain tile. And just to do this a clean way, so you don't get confused later on, let's say we include a custom tile 15 here. Now normally that would just still say tile 15 over here. So we don't want we don't want it to say tile 15. We want a specific name for it. Our super tile, for example. So if we have some code for our super tile and we attach it to tile 15 here, it's a good idea to go over here to project labels, tile types, and here we can give that tile a name, a descriptive name. You can see we already have some up here. So that's just the basic of how we can include some custom tiles in our script. So let's just start by looking at let's see here. Let's start by looking at the checkpoint tile in my game. The checkpoint tile is actually placed right here at the beginning of the level. So if we click collision here, you can see here it says 0B. Now I'm sure you know this, but these are hexadecimal values. So 0B, that's what's that in oh my god. 0B, that's 12. You know what? I need to check. My mind isn't working right today. Okay, anyway, we have our calculator. So if we're unsure about that, we can just go here to our calculator and it can convert it for us. So I'm gonna check hexadecimal here and I click B. And we can see here that B is 11. Okay, so B in hexadecimal is 11. That means that this is tile 11. All right. So I have a checkpoint tile here. Now the way tiles work is that whenever an object collides with the tile, then the tile code is triggered. So when my player object collides with this tile, this checkpoint tile, then the checkpoint tile code is triggered. So in this case, I made it invisible. I didn't want, you could have a sort of a flag or whatever as a checkpoint. And whenever you collide with the checkpoint, the flag's raised or whatever. So you could do that. I just wanted a blank tile, and this is my checkpoint. So how does the checkpoint code, what does that look like? Let's go to our project settings, script settings, and let's go down here to tile 11. That says checkpoint base here, so that's the correct tile. So if we go to edit over here, this is the code for our checkpoint tile. So let's just quickly go through to see what this does. And before we continue, just a little heads up. This episode is going to be very technical. We can't look at tile types without looking at assembly code, because tiles are basically assembly code. That's all they are, with a little graphic attached to them. But basically, tiles are pure assembly code. So, in our checkpoint tile, you have to start at the top here. So, what this does, this first thing right here, without going too much into detail, because this can get super technical, but the basics here, this part right here, it just checks if the screen is being updated at this specific point in time. Why is that important? Well, it's important because later on here we're going to change this tile. So we're going to change the collision and, most importantly, the graphics of our tile. Now, as I said earlier, in this specific case, I'm not really changing any graphics because this is a blue tile or a blank tile. But we could have, as I said, we could have a flag pole that when you touched the checkpoint tile, a flag was raised or something like that, you know. But the point is, we are going to change this tile. So we put a check here at the beginning that says, is the screen being updated right now? If it is being updated, then we go here, RTS. And if you have worked with assembly code, I'm sure you know that RTS is sort of a quit command, return from subroutine. That means that if we get to this part in our script, then we quit out of this code and the rest won't be run. So, okay, that's a little weird, isn't it? That means that we run the risk of not running this code, this tile code? Well, not really. Here's the clever thing. So when an object collides with a tile, that code is being run all the time as long as the object is colliding with the tile. Not just the first collision, but as long as the object is touching the tile, then the tile code is being run. So that means in this case that if the screen was being updated at the moment the let's say it was a player object, so at the moment the player object collided with the tile, the screen was being updated. Alright, so we quit this code, but that's no problem, because in a split second, remember, everything is happening super fast, so in just a split second this code is being run all over again, and maybe the screen is being updated again, no problem, just another split second and the code is being run again. So I can basically guarantee that this code is going to be run when you collide with this tile, because it's happening so many times that that we will run this code, even though there's a certain condition where the screen is being updated exactly when we collide with the tile. I hope this isn't too confusing. Basically, this part just makes sure that we don't run this if the screen is being updated. Now, let me just give the reason why we do this check. If we don't do this check, and down here we change the tile, then there's a big chance that we will get corrupted graphics, because as the screen is being updated, it's drawing the screen, and if we change something while the screen is being drawn, then that's the kind of case where you get corrupt graphics, weird graphics, and that doesn't look good. So in order to prevent that, we have this little check here at the top. So if we run this, the screen is not being updated, then we continue on. So let's just do that. Let's continue on. Let's say in this case we're lucky and the screen is not being updated, so we continue on down here. CPX player 1 object. This is just a check to see what object collided with the tile. Was it the player object? Well, if it was, branch if equal, which means if it was the player, then go here, do checkpoint, which is this thing. So if it's the player object, then we continue the code down here. But if it's not the player object, then we go here, and this part says JMP skip, which means jump to where it says skip, which is down here. And in simple terms, that means that if the object colliding with the tile is not the player, let's say it's a monster, then go to skip and it skips this part. So if a monster collides with a checkpoint tile, nothing happens really. But if the player collides with this tile, then we can continue on from here. So what really happens here? Well, LDA is load, as I'm sure you know. So we're loading the object screen, comma X. And again, if you've been working with assembly code in NESmaker, you know that when it says comma X like this, that usually means that this is an object, and the comma X is the object that's loaded into X at this moment. So that means that we did a check. Is this the player? Yes. We jump down here. So by the time we get down here, we know that the player object is loaded into X. Okay. So object screen, what's that? Well, every object has this object variable, and that keeps track of what screen this object is on. And the player is obviously going to have the screen that we can see at any given time. It's going to have that screen in here. Okay, let's not get too much into detail here, but we're loading the screen that the player is on. We're storing it into continue screen. We are loading object x high, which is what x value, what horizontal value does the player have. We're storing that into this variable continue x, and we do the same thing with the y position. So basically we do three things here. We save what screen are we on, what's the x and y position, and we store those in separate variables. And this part, I didn't make this part of the script, but I think that it's sort of a security measure from Joe, where you just stop the speed of the player to avoid any scrolling or anything like that, I'm guessing. Because when you load 0 into these variables, then you stop the movement of the object. And finally, change tile at collision. That's a macro. And what this macro does, it changes the graphics of a tile and it changes the collision type of a tile. So let's quickly look at this. Change tile at collision. I've written 32 here. So what does that mean? That's tile 32, right? Not quite. Let's go to our NESmaker over here. And let's go to our pixel editor. And let's load our background tiles, the first one. So this is what we're used to seeing, right? When we're drawing our background tiles, this is what we see. And it said here, change tile at collision to 32. Alright, 32. Now, always in NESmaker, when we're working with windows like this, we start by counting on the top left from 0. So let's try that. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So you actually don't have 32 tiles here. So that can be a little confusing. Why do we write 32? We want to change this the first one is the graphics. The second one here is the tile collision type. So 0, that's null. That's a null tile. But this graphics thing, 32. Alright. So, maybe you have heard people talking about meta tiles on the NES. So what's a meta tile? Well, a meta tile is that's the normal background tiles that we use. Those are meta tiles. And the reason they're called meta tiles is because every single tile that we use is made up from 4 smaller tiles, like this. So this meta tile, this first one, is made up of these 4 smaller tiles. And when we're working with sprites, we're used to working with these smaller tiles. But we don't think about it when we are making backgrounds. Then we're used to just working with these larger tiles. But also these larger tiles are made up of smaller tiles. So our meta tile here is made up of these. Okay. Well, so why do I write 32 here? Well, the thing is we can't, in NESmaker in this case, we can't specify a tile number like we're used to. we have to specify one of the smaller tiles. So we have to click this 8 by 8 button, and we have to start counting like this, and again from 0 in the top left corner, 0, 1, 2, 3, 4, 5, 6, 7, and we get down to here, which is 16, and blah blah blah, blah over here we get to 32. That's this one. And so this one right here, that's this tile. And what NESmaker does, it constructs the rest of this tile. So we just have to specify the top left part of the tile that we want. Let's say I instead of 32 I wrote 33, which is this tile. If I wrote that, then the tile would end up looking like half of this and the left half of this egg. That would be the new tile. So just remember that if you use the macro called change tile at collision, you need to specify the top left tile of whatever tile we're using. And again, start counting from the top left over here and over here. So 0, 1, 2, 3, and so on. Okay. So change tile to this blue tile that we just saw, and it's changed the collision type to 0. Alright. So we have saved the screen and the position of the player, and we have changed the tile. Now, this is usually a good idea for any tile types that you want to change somehow. Because if you don't, as I said before, the tile code is being run all the time as long as you're colliding with the tile. And in some cases, that could actually crash the game. So change tile at collision could, oftentimes at least, be very wise to use on tiles that need to change. Okay. So what's the point of this tile? Well, if you have played video games before, then you probably know that checkpoints are the place where you continue on from. Let's say you died and you want to continue from the last checkpoint. Obviously, that's what we're doing here. So these variables, continue screen, continue X, continue Y. Before we let this one go, let's just quickly take a look at our script settings. And now let's not make this too complicated. You get the idea, right? These values are being used later on to tell the game where we want our player to spawn after he is dead. That's the checkpoint tile. Okay, let's not spend any more time with that. Let's just instead look at another tile. So we have seen our checkpoint tile, and let's take a look at the trampoline tile. So again, the trampoline tile by default, it is a default script, but I modified it. So by default, the trampoline tile checks if it's the player, and if it's not the player, then do nothing. I don't want that in this game. I want every object to be able to bounce on my trampoline tiles. That means that monsters can bounce on it, objects can bounce on it, anything can bounce on my trampoline tile. So I removed the check from the default trampoline tile that says CPX player 1 object, because I don't want this to only apply to the player. So let's take a look at the code. We are loading V speed high. What's that? Well, that's the vertical speed. Speed up and down. So we're loading that, and comma x, that's for the object that's colliding with this tile. So the object that's colliding with this tile, what vertical speed does it have? Well, when we get this part and we write BEQ, that's branch if equal. Normally we would write something like this: compare with 0. And branch if equal, is it 0? But 0 is a special case. So if you're going to compare with 0, you don't have to write CMP0. You can just write BEQ right after. So load this, and if this is 0, branch if equal, go to skip. And that skips this tile. So what does that mean? Well, the vertical speed. Is the vertical speed 0? Well, that means that the object is not moving up or down. It can be moving sideways, right? But it's not moving up or down. That means that if an object collides with this trampoline tile from the side, nothing's going to happen, because the vertical speed is 0. So we go down here to skip. Alright, what about this next one? BMI, branch on minus. If the vertical speed has a minus value or a negative value, and by the way, let's not go into negative values in assembly language because that's a little complicated. But for now, let's just say that if this object has a negative value, which means it's going up. We're loading the vertical speed and we check branch if minus, is it going up? Well, if it's going up, branch on minus, then go to skip this time too. So if it's 0, we skip, and if it's a negative value, we skip. Which means that if you jump from below the trampoline tile, collide with it from the bottom, nothing's going to happen. It's not going to give you an extra boost or anything, because in our code we said if the vertical speed is negative, then skip this code. Alright, so we don't run this code if the vertical speed is 0, we don't run it if the vertical speed is a negative value. But what about if it's none of those two? That must mean that the vertical speed has a positive value. That means that the sprite is going down. Alright, well, if it's going down, the vertical speed has a positive value, it's going down, and it collides with this tile. Alright, then, because it's not 0, it's not negative, alright, then we continue on. Then that's when our trampoline effect is being run. And what happens here? Again, a lot of technical stuff here, but we are loading the hexadecimal value F8. Right, obviously, right? Well, hexadecimal F8. Again, without being too technical now, that's a negative value. So we are loading a negative number and we're storing it into the object vertical speed. That means that we are giving the object boost. We're setting a negative value and we're giving it a speed that's going to move it up. That's what this part does. So the object is colliding on the trampoline tile from the top. It has a positive value. And when it collides with this tile, in this code, we have something that gives it a negative value. That's going to move the object up. And obviously, that will give a trampoline effect. Also, so that's what we're doing with the object. But we're also doing something else here. We are loading tile X. We're doing some stuff with ones and zeros. tile Y, ones and zeros, and again we're loading the object screen that this particular object is on. So what's going on here then? Well, what's going on is that we are saving the exact position of the tile, the trampoline tile. We want the exact pixel position of this tile, exact position of that, and this part is what screen is this going on? What screen is the object on? So we're loading those three things, and we are creating a new object with the values that we just collected. The X position of the tile, the Y position of the tile, and the screen that this is happening on. So what object are we creating? Well, we are creating an object called object 11. What's that? Let's take a look. So when you go to our game objects, again, we always start counting from 0, and the player is always object 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is object 11. Alright, so we are creating that object. This next part is what object state should the object have at the moment we're creating it. And I just want this to be created with the default object state 0. Remember, we're talking about this thing now, action step or action state. I want this object to be created with the first one, object state 0. And as you can see, this does a couple of things. So I'm creating a new object with these values. So this object will be created at the exact same place as the tile. We're creating this 11 object with action state 0. This thing right now, don't worry too much about that. It just means that we have to preserve our X value so that we don't corrupt it when we're creating a new object. Let's not worry too much about that for now. But the point is, for a trampoline tile, we have changed the vertical speed of the object, and we have created a new object on top of the trampoline tile. And that's it. We're done with this tile, with this code. So let's just quickly look at this object that we're creating. Well, I'm sure you can see that it looks almost like the trampoline tile itself. Let's take a look at our trampoline tile. It's over here. So it looks almost like this one. Now, the reason I did this was to give the trampoline sort of a bouncing effect. So when the object collides with the trampoline tile, this object is created on top of that tile. And I made sure that the graphics matched the color of the background, and I made sure that this covers the entire trampoline tile. So it gives the effect that the trampoline tile has a little bounce. This is something I figured out a few weeks ago, and I wrote a tutorial on that on the NESmaker forum. So I'll leave the link in the description below. So that's the trampoline tile. Let's just say that that's enough for this tile. We have looked at the checkpoint tile. We have looked at the trampoline tile. So what about this egg tile? Okay, let's take a look at our egg tile. Now, just to be clear, we are talking about this thing, which is 0C. So this has its own collision type, and that's this thing, the egg tile. Now it has a little bit more code, so again, let's not go too much into detail, but we're starting off here by doing the exact same thing that we did with the checkpoint tile. We're checking to see if the screen is being updated, because this tile is going to be changed as well. So we don't want this glitchy graphic issue. So I'm putting this at the top, and I'm not checking if this is a player object or not, which means that any object can collide with this tile. And I'm getting the X and Y position and screen. Now you probably will see this several times, because this is a way to collect a specific position and use that information later on and create an object at a certain position. So in this case, I'm collecting the X and Y value and the screen of whatever object collided with this tile. And next, I'm changing tile at collision again. And just like before, this is small tile 32. And if you remember, that's the top left part of the blue tile. So this and 0, collision type 0. This will just change this tile to a blue null tile, which means that visually the player will just see an egg tile and collide with it, and it will just go away, give the illusion that he collected the tile or the egg. So the next thing, JSR do wait frame. It's kind of similar to this thing actually. Just waiting a single frame, not a second, just a single tiny little frame to avoid any glitchy graphics, or glitchy graphics. We don't want that. We just wait one frame before we continue. And sometimes when you're using the change tile at collision macro, can be a good idea, especially if you have this issue. You have made your own tile, you're colliding with it, and especially on scrolling levels. The screen is scrolling, and while it's scrolling, you're colliding with this tile, which has this change tile at collision. So the tile is being changed as you scroll the screen. And that's usually you'll get some sort of glitchy effect. So usually it's a good idea to put a JSR do wait frame right after the change tile at collision, especially like in this case, where it's likely that the screen will be scrolling while the player is colliding with this tile. Because I have a lot of egg tiles on this level, and it's very likely that the screen will be scrolling when we're colliding with this tile. So that's why I put this wait frame right after the change tile at collision. Okay, so now we get to the part of the egg tile where we are checking if it's the player object or not. Now we are going to worry about that. So is this the player object? Well, let's say that it's not the player object. Let's say a monster collided with this egg tile. Okay, is this the player object? Branch if not equal to not player. So if it's not the player object, we go down here to not player. So what's happening here? Well, I have a variable called myEggs. So we're loading myEggs, and I wrote the CMP0 just to show you what we were talking about earlier. But in fact, as I just told you, when we're talking about comparing with 0, you actually don't have to write CMP0. This only applies to 0, but we don't have to write CMP0. So I'll just remove that. So I'm loading my eggs, and branch if not equal. So, which means that, is it 0? Branch if not equal, branch if equal, that's if it is 0. Branch if not equal means that it's not 0. Okay, let's put this another way. It means that it has a value. So we're loading my eggs. Does it have a value? Yes. Alright, and go down here to steal eggs. So if it's 0, we go down to this thing, JMP done egg tile, which basically means we're done with this. The logic behind that is that if the variable my eggs is 0, then there are no eggs to steal for this monster. But if it's 1 or more, then the monster can steal our eggs from us. So BNE, branch if not equal, which means the number is not 0. Right, we go down here, and here we are loading 1 and storing that into temp, the temp variable. Why are we doing that? Well, I wrote a little comment behind here that says action state 1. Alright, so this number 1 is going to represent an action state. Alright, let's just try to remember that. So we're loading that into temp. And remember, this is the monster colliding with the egg tile. Now we are DEC, decrement, or decrease. So we're decreasing my eggs variable. So if it was 1, of course it goes down by 1 to 0. If it was 2, it's going to go down to 1, so on. So we are decreasing my eggs, the variable my eggs. And we're playing a sad laser sound here. And then we get to a part that says create point object. Alright, what's going on here? Well, basically the same that we have already looked at. You're creating a new object. And by the way, when you're creating scrolling levels, there are 2 macros that has to do with creating new objects. If you're using, if you're doing this on scrolling levels, then use the one called create object on screen, not the one called create object, because create object on screen has an argument for what screen this is, and that's important for scrolling levels. So on scrolling levels we need to use create object on screen. Alright, so again we're creating a new object with the x and y value that we collected up here. We are creating object number 14. Alright, what's object 14? Well, that's this object. It says +1 here. Okay, so we are creating this object. Alright, what else? Well, the next thing, that's the, as you can see here, that's the beginning state. What action state do we want at the moment that we're creating this new object? What action state do we want for it? Well, if you remember what I showed you before on the trampoline tile, I was creating a new object there and I wrote 0. I wanted that new bounce object for my trampoline to have action state 0. Now, I don't do that in this case. I don't write 0 in here. Instead, I use a variable called temp. So whatever is in my variable temp right now, that will be the action state for this new object. And just a second ago, we saw that we were loading a 1 and storing it into temp. Which means in this case, this new object will be created with action state 1. And this last one is just what screen this is happening on. So what's this action state 1 thing? Remember, this is a monster colliding with the egg tile. So if the monster collides with an egg tile, this object will be created. But it's going to be created with action step 1. And action step 1 has this animation type. So it's not going to have it's not going to play this action step 0. It's not going to do that at all. We're going directly to action step 1 for this object. This is a new object created with action step 1. Why am I doing this? Well, animation type deck. Let's look at the animation type deck. Okay, so that's this one. So if a monster is colliding with the egg tile, then this new point object is going to be created with action step 1 with this animation type. And if we look at the go back to our code here, our egg tile code, and let's go back to where we are comparing if it's the player or not. So if it is the player object, then we go into here, and now we are loading a 0 into temp. So now we are loading action set 0 into temp. We are basically doing kind of the reverse of the other. So now we are increasing the egg variable. Don't worry about this right now. But we are storing a 0, blah 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 blah. You get down to create point object, and what's in temp right now? Well, if it was the player object colliding with our egg tile, then it's a 0 loaded into temp. So if the player collides with the egg tile, this new point object will be created with action step 0, and that has this animation type, ink. This. So if it's the player that's colliding with our egg tile, then this new point object will be created with action step 0. That has this animation type. So the effect I want from this is that the monster is colliding with an egg tile, and a -1 will show up on the screen. Now, I'm guessing that this will make sense to the player who's playing this. He will know nothing about all this assembly thing, but I'm thinking that this will make sense. A monster collided with an egg, we get this -1. A player is colliding with an egg, and whoever plays this game will see a +1. I think that makes sense visually. So the way we do that, as you just saw, is that we check if it's the player or not, and we load 0 or 1 into temp based on if it's the player object or not. So this is just a clever way of making a little more clever code. We could have made a lot of different things here and let's not go into what we could have done, but this is a pretty decent way of doing it. We are just using create object once here, and by the way, if you can do it this way, then that's a great thing, because we are saving space. We could have written create object both on this part and on this part, but whenever you're using a macro, that takes up a lot of space. Let me show you very quickly what I'm talking about. Let's just go to create object on screen. That's this one. So every time we write create object on screen, every time we write that, that basically puts all of this code into the code that we're writing right here. So that's why using macros can take up a lot of space in your game. If you're using tons of macros, then you're going to run out of space very quickly, because every time we write the name of the macro like this, it's basically when we are assembling this code, the assembler is going to replace the name of the macro with the code. So all of this code will be pasted into our main code. Okay, again, let's not go way into detail, but just a little fact for you. So the point was, if we just use this once, we save some space in our code. And if you always do it this way, then you are making efficient code. You are saving a lot of space. So whenever you can write like this, write something once, then it's best to do it. And we can have a different result based on whatever we put in our variables. Like in this case, I put a 0 up here for the player. If it was not the player, I put a 1 in there. And by the time we get down here, we can have a different result. We can create an object with a different state based on whatever object it was. Now again, I hope that that makes sense. It can be a little difficult to explain a lot of this assembly code because some of it is pretty complicated, and especially if you're not used to working with assembly code, then it very quickly gets overwhelming. But as I said in the beginning of this video, if you want to make custom tiles, then there's no way around it. You have to use assembly code to make those tiles. Alright. Now I know that was probably a lot, but again, this is all about, this episode is all about custom tiles. So let's just quickly take a look at, by the way, we had our own custom hurt tile. So actually that's our last one. We have looked at checkpoint, trampoline and egg tile. Yeah, so this works out great because this hurt tile is a little special. If we go down to our tiles, which is here. So again, hurt tile is, there's a default hurt tile in NESmaker, and it has some default stuff in there. But I've made my own custom hurt tile. Let's quickly take a look at that. So I'm going to select my hurt tile and click edit. And this is what my hurt tile does. We check if it's the player. If it's not the player, then don't do this. We skip down here. But if it is the player, then we do this. Yeah. So you know what? This is the perfect time to end this episode, because in the next episode we're going to look at exactly this. This is going to be way too much to include in this episode as well, because as you can see, I made my own custom subroutine here. I made a subroutine called player death, because what happens in the default NESmaker setup is that there's a player death code for the hurt tile, and there's a player death code inside the hurt player script. And I think by default they're pretty much the same. And if you're never going to change that, then that's no problem. But if you want some sort of custom player death thing going on, maybe you want to create a player death object and you want to play some sad music or whatever you want, and you want to change that later on, then it's so much better to have all of that code in one place. You don't want to go updating your hurt tile and your player hurt player code, where you have basically a duplicate of the code. Yeah, in one place, in two places. Sorry. So my point is that the next episode we will look at creating our custom player death code. And just to give you a little sneak peek, that's this part right down here. So as you can see here, I no longer just have handle player hurt, I also have something called handle player death. Yeah. Well, this was a lot of stuff, a lot of assembly code, and I did a lot of rambling here, but hopefully you got something out of this. You could see how you could make your own custom tiles, but as you can see, you will have to use some assembly coding to make your own tiles. But if you're not comfortable with that, then there's always the NESmaker forum, where there are a lot of tile types pre-made for you. So that's always an option. Okay, well, you know what? That's enough for now. Let it all just sink in, and I'll see you next time with our custom player death script. Alright, bye bye.